Hello, everyone, and welcome to today's webinar. Our focus today is blower door testing for insulators, so it's kind of a basic overview. Usually the webinars, I try to make them last around 45 minutes, maybe 50 minutes, just so you understand the time frame. But it is a challenge to cover this type of topic and feel as though everybody got some information they were looking for without really being too in-depth or being too basic. So I try to make sure we cover a variety of options for everyone who may be here today. So my name is Joe Medosh, and also with me today is Jay West. We are trainers for Retrotec, and we host these webinars from folks who actually come from the industry, and would gladly answer any of your questions as we go and make sure you get all the information you're after today. A few basic things we always cover quickly. The webinar control panel, it may be very small for you. You can click the arrow to make it larger. That's what will actually control your sound. And confirming I do have sound, because I requesting now. So if you have any information, or if you can tell me that you can hear me, then confirm that I'm actually coming across. And you can enter your information in the little, it's good. Thank you, Mike. Enter your information in the question area. This is not just for questions. This actually is for any information that may be a question, but it may be something else that you have about this topic, or something similar, or something I did not cover, or suggestions for next webinar. So don't hesitate to feel it has to just be a question pertaining to that exact slide. So confirming now, if you do not have sound, you definitely want to check your settings. I bring up a few basic slides to kind of make sure you understand where a lot of this information comes from. Retrotec.com has revamped their website, and it's very user-friendly, and it's got some amazing resources, and every day only gets better and better. It has a phenomenal library that actually includes a variety of not just quick guides, but also manuals. So under support, you can find manuals and guides. That's also where you can find the webinars or register for webinars like you've done today. Many of you may have received a direct email from one of your groups, but if you want to know what's going on next, you can go to that page. You can also log in or sign up and get regular emails. One of the things that I do love about what Retrotec does is how they create their quick guides. This is the visual quick guide that I just showed in front of you. I have a few that will be throughout the presentation today. They're very visual with little check boxes to actually help your QA process. So it is a how-to process. They also have manuals which are much more in-depth about the actual process. Some of those can be sometimes a couple hundred pages that get in-depth into air leakage testing systems, but many of them are just quick guides that actually will step you through the process you're working with. The quick guides do have some really valuable information. Like here's one on the back of the blower door and the duct tester on how to actually do a field check of your gauge. This works with any gauge, whether you have a Retrotec gauge, the DM2, or the Minneapolis DG700, or the DM32, the new one from Retrotec. Also on there's also a system on how to actually kind of do a field check of your fan itself. So these are some really valuable ways to actually do QA as a process and make sure your quality control is going well. So a couple people said there's still no sound, so just confirm where a sound. Bob may have a challenge with his setup. Somebody talked about the App Store already. How do you get the app? You can get the app, which are either Apple or Android, either from their own Play Store. You can search Retrotec or Gauge Remote with no spaces, or you can also get it directly from the Retrotec site. I do like to also kind of mention our partners. IDI Distributors is one place besides directly with Retrotec that you can also purchase your blower door fan and gauges or other accessories that you may need. So we welcome IDI to what we're doing, and we're really excited about working with those guys. I met many of them at the Insulation Contractor Association of America conference just last week. It was an awesome group and a really unique venue where they didn't have a lot of trade actual breakout sessions. It was mostly about, being a better person almost, and being a better contractor, and being a better business person. So I was kind of impressed by how they actually did their sessions. It was really well done. We also are a member of the High Performance Insulation Professionals. I misspelled your hip there, so I'll move on past that. If you are looking for issues about ventilation, we highly recommend that you go to Residential Energy Dynamics. When we talk about blower doors and how tight the house is, the next thing that people bring up is the house too tight? And one of the ways you can actually determine that is by going to Residential Energy Dynamics, or RED. And there's lots of features on their site that are free and allow you to determine your ventilation standards or requirements based upon your either code or your standards. Here's some things that I hope to cover today in our time frame. How simple a blower door is to set up, to run, to get the numbers, and some code or testing requirements that actually go along with the tests that are there. And really that this is ultimate control test. This actually will help you do quality control, and also kind of gives you a great checks and balance for your quality assurance systems. There's some other blower door opportunities or applications that I'll kind of touch base on. And in general, hopefully you'll see ways that the blower door can be used to increase your sales, from either marketing or showing what you do for other contractors, adding more services to contractors. One of the things I did notice at the ACAA conference was a variety of people that also do closet installations or other similar things for contractors. These are the basic elements that we'll need to do a blower door test. Obviously, we need a fan. These are all calibrated fans. In general, there's mostly two companies, Retrotec and Energy Conservatory. There are other brands that are much more difficult to get a hold of or find from Infotech, but in general, there's two main companies that do that. You will need a frame. You'll need a shroud or a cloth to use with the frame to actually separate the interior and exterior. And you'll need a gauge to actually read the fan pressures and actually the pressures in and out of the house. These are the systems that it's a complete system that comes from Retrotec. And I got to tell you that, again, I don't really work for them directly, but I've always been interested in what they did. That's why I came to them to help them with their training and some of their marketing, is because they really dig into the details. They always are updating their gauge, their fan, their entire system. It does not sit still. And I think that actually screams pretty loud as to what our industry is always doing. So if you're whatever part of the industry you're in, we know that everything has changed in the last 6 months, 1 year, 3 years. So Retrotec really strives to keep up with that, to make things better, faster, simpler, better solutions for how you actually test. So when you get your system, you really feel as though you do have all the accessories and all the things you need to do your tests. Again, here's another shot of the entire system as it comes. I did mention earlier about the quick guys, and I can't stress these enough. And the one on the right for the gauge, the DM32, is smaller because they actually made it smaller to fit in the case that the gauge comes with. So again, they are trying to become much more practical. So there's one how to set up the fan, how to actually do the blower door tests, and one about setting up your gauge. So they really do kind of take you through with a nice visual process. I'm going to get into how to do a test kind of in basic terms. And one of the first things we're really doing is we're sealing the entire house so we can test it. All right. So there's some basic things that I always encourage people to check, which sometimes aren't really part of a checklist, but you need to know what the crawl space looks like. If it's full of moisture or some type of fungal growth or some issues or has some major openings between the living space and the crawl space, it's not the time to do a blower door test. Same with the attic. If it's got a variety of issues or openings, is the duct system have any concerns? Many people may be doing newer homes, so these things are always less common than existing homes. But I'm sure we've all been into brand new homes and realized that there's ducts that are disconnected, vent pipes that are separated. So there's a lot of things that actually become issues. And you want to make sure all the doors you're not using get locked or get secured, and you want to make sure that the garage is well separated. Some things you're going to do to prepare the house. I'm just going to kind of go these quickly. You basically just want to go through and make sure your priorities are taken care of. So all the windows and again other doors are closed and locked. Any fireplace, make sure the ashes are fully cold, and you can put some wet paper on them. And you don't want that stuff to get pulled into the room. Make sure the damper's closed. Anything that moves air gets turned off. Gas appliances, even for a new home, you want to make sure that like the hot water tank is set to pilot. Your HVA system is either set to off, or you've actually adjusted the temperature so it won't actually come on. The little picture here I have may be hard to see, but if you're going to mess with anybody's pilot light for their hot water, it's an industry practice to just put your keys there so you cannot leave and they end up with cold water the next day. Another one is to pour water into the traps if it's a new structure. Someone was asked, is it possible to use the DG 700 manometer with a Retrotec 1000 and vice versa? The question is that can I use the DG 700 energy conservatory gauge with the Retrotec fan? And there's actually fan curves that are built into how the fan works with the ranges and the rings, and all that must be built into the gauge to give you accurate results or the mode results. So the DG700 doesn't have that built in, but the Retrotec DM32 not only can read the Minneapolis blower door fan, but it also can control it. There's an adapter that you can have to control that. Someone asked early, is there a method for depressurizing large buildings to use thermal imaging cameras? Oh, yeah, that's actually a very, we're talking like 3,800 square feet. At the end, I kind of go through some off-topic kind of stuff with that. So, Ron, if you're around at the end, I gladly will go through some of that, but that's actually a fairly easy solution. It just requires more fans, basically. You're mostly after when you're doing the preparing the house and the test is to do no harm. If anybody here is BPI certified, that's one of their mantras. Make sure we're not backdrafting, causing combustion gases or ceiling tiles to fall down or dust or debris to come in, or worst case, fireplace ashes to come flying into the house. So your goal is just to make sure we do things well. I made this yesterday with my son. This is going to move really quick. This is actually bringing in the entire blower door equipment, setting it up in the doorway, and basically kind of putting the gauge together and doing some basic setups. As it goes, I'll try and narrate it. There is some slides that have text on it. Please don't feel overwhelmed that it went by really, really fast. I'm going to tweak this and put this up on the Retrotec site and on YouTube, and so people can kind of get an idea. I feel the YouTube videos are great because you can stop, pause them, and play as you want. So my goal is to kind of tweak this a little bit so I'll be able to do that. So make sure you're buckled up. Here we go. So we basically brought the equipment in. We're setting it up. It goes into the door. We're holding our foot down on the bottom to secure it. Use your elbows to kind of tighten it, and the crossbars. So once I have the cloth on, I can actually now make sure everything's secured, put the actual cam locks on, and make sure it's really secure in the door. I'll now get out the umbilical and the power. The umbilical must go outside. The red hose goes outside. It was going through the red door, and it must be far away from the fan. Fan gets put in and gets strapped up. I'm going to make the connections to the fan. The yellow hose goes to the yellow fan. The red's clearly going through the cloth. I add the manometer. It's all color-coded, simple connections. A clip on the back that holds it. I add power. Power's on. And I set up the DM32. Again, I'm following my quick guides. And I make sure I got the right fan. I capture a baseline. Depends on how windy it is. It may differ how long I let it go. I uncover the fan. These are the different ranges that the fan has. I can actually start by checking 25 pascals. Is something I preach and do. Check the house, make sure there's no issues. and now I can actually go to 50 and get my test, and it starts all over again. So um, hopefully, if you're brand new to using the blower door, you got all that down and you're ready for the test. But my goal was to try and make something that did move kind of quick and showed you just kind of how the connections went. Of all the tests that most people do as an energy auditor, I personally feel the blower door is one of the simplest, somewhat quickest, and sometimes it takes longer to really get it out of your car and get it all the way up, or check a few things, but than to actually run this entire test. I'm gonna let it finish off the second time around. So I got all my crossbars in. I leave a little bit of room in the frame, so now when I take it out and I put the cloth on it, there's a little bit of room to put it back in. So I don't actually make the first set of frame alignment really tight. So there's a little bit of room. It's easy to get it back in now. Now I'm going to loosen and resecure all of the knobs and make sure that I'm actually either using my thumb to push on the side with my elbow or step on the bottom and push up. Again, make sure it's all the way in and really snug. Most of the other setup that goes along here is all easily followed by the quick guides. You do want to make sure that your reference tube is far away from the fan as possible outside. It should not be in water, or if it's a really windy day, you may actually extend that tubing so it goes around other parts of the house. Jay actually has a variety of methods of putting it in a system where it actually has dirt or you can bury it. But your goal is to make sure that it actually is not really sitting directly in the wind. And once you set it up and get everything running, it's really easy to get your results. And then I can determine how well this house was sealed, how well the job I did or others did, and I can compare this house to other houses that may be older or newer, or actually different sizes. Is one of the things that actually kind of allows it to do. So the new frame that Retrotec has actually snaps together. It's a nice system. You can actually kind of like torque or rack the whole frame, and it'll actually separate for you. I did not have that in the video, or you can just press the buttons and it comes apart. I did have a simple animation that just kind of shows again how this kind of goes together. Most people set it up on the floor. You got all your parts. It goes into the side. You add your crossbars. I add the cloth. Now, when I add the manometer, this is the DM32. Channel A is on top, and channel B is on the bottom. So channel A is going to read the pressures of the fan, all right, and channel B is actually going to give me the results that are actually being converted to CFM or anything else I want to do for that. So as you look at it, red is channel A. You can see that it actually goes through the red cloth going outside. And that helps me determine the pressure between inside and outside, and that's my test pressure. So channel A is on the top. Put those back again. So channel A is on the top. So red is referencing the outside to the inside. And that's how I get my channel A test pressure of 50 pascals. And B is actually going over to the fan and gives me my actual result at CFM. I have this slide that kind of explains the blower door, and there's other options that you can do with the blower door that kind of refer back to this slide. So hopefully it will make sense, or when I refer back to it, you'll understand the concept. We actually test at 50 pascals, which is a pressure measurement. And 1 pascal is an incredibly light amount of pressure. Some people describe it as a post-it note on your hand, is that amount of pressure. Some people kind of describe it as, your lips kind of separating just themselves. It's just such a subtle amount of pressure. And so we're going to test the blower door to a depressurization, which means it's negative 50 pascals, which means I'm going to be pulling all of the air inside the house to the outside. So if you think about in general terms of pressure, that if I have 50 pascals moving out of the house, then in theory, I must have 50 pascals moving into the house. So pascals, again, is a pressure, but it helps visualize some of the other things you can do with your blower door while it's actually running. Basically, how it works is there's a small sensor inside the middle of the fan that it's able to actually convert that pressure to CFM. So we're basically set up the fan so it has pressures from inside and outside, and basically from inside compared to the fan. It converts the results or the pressure to CFM or cubic feet per minute. That's how we're able to use that for comparison or compliance, and it makes things much more standardized. One of the things I'll bring up is code, and the reason I have just the 2012 is that only Georgia that I know of actually requires blower door testing under the 2009 code. So if you have another code that actually requires blower door testing that's not 2012, then let us know. That would be great to have. So the other question, which I try to avoid polls because they kind of slow things down, but if you could give me a clue as to what code are you currently on, and does it require blower door testing? So if you could tell me if it's 2009 or 12, and are you actually required to do a blower door test? So in the questions, that would help a lot. The requirements are incredibly simple. The code blower door section is only, for the most part, kind of part of a page. It's not an in-depth testing protocol, or doesn't really have a lot of information about how to do the test. Most of the people that are doing the test come from a background that made sure they were trained, either BPI or ResNet. Maybe they were home performance with Energy Star, or there's a DET special training that a lot of states have adopted. That's a duct and envelope tester verifier, basically, that allows you to do just kind of new homes. It's great for I personally think it's great for the industry because it allows people to do new homes and increases the need for what we have to complete for this kind of a challenge. So the more people that can do the test, then it's easy to say the test can be done. So doing a blower door and determining compliance is based upon air changes per hour. So we're going to convert CFM, cubic feet per minute, into a air changes per hour. Which basically means how much air moves through the house. So these are the requirements for 2012. And their setup is very simple. It just kind of says, close things to go to the outside, and do not seal this. Make sure this stays open. And this compared to ResNet is about 28 pages of standards and what to do and how to do them, and making sure you're doing things correctly. And they give you much more testing options. It's much more stringent, but here it's a very basic type of test. In the code book, and it still is in the code book, is this list of 17 items that are supposed to be visually checked, even if you do a blower door test. And I highly recommend that these things get visually checked. If you're going to be testing the house, if you're doing air sealing, or if you're only doing part of the air sealing, this is something you must focus on. I personally feel that if these are usually visually checked, the home almost always will pass unless some catastrophe happened or caused it to change its leakage. So these numbers here are all associated with a certain area. And we build these houses, and they're nice walls. We have all these things we're putting into them, and then we go and we cut all these holes in them. So now we have all these windows and doors and separations and vents to the roof and receptacles and connections for AC units, and a variety of stuff that's also inside the house, which doesn't show up here, is all of the wall framing that we have that has connections to the attic or crawl space directly in the inside of the house. So we kind of make Swiss cheese out of the homes we build, and they're expecting somebody to be responsible for the air sealing. And when I was at the conference last week, I asked how many folks were doing air sealing, and about 80 90+% all said they were doing air sealing. I didn't get a confirmation on people were testing their air sealing, but the fact that you're taking on the responsibility for this, it won't be long before you'll be required to test it and make sure it does pass. And as I described in other webinars, if I fell and bruised my arm heavily, I don't think anybody could really look at it and tell me it's fractured. You must actually have it tested or evaluated by a professional to determine really how well it leaks. The point is you cannot actually look at a structure and determine how leaky it really is. So these illustrations actually come from South Face Institute, and you can find them online. Every week we try and follow up about a week later with this actual presentation. We usually create a video, and we'll create some links on a PDF. So we'll have the links of what these are. I did the IDI about a month ago, and I had some challenges with moving, so I'll make sure that you guys get these links. So here's some examples of, this actually is the eave over here by this bathroom. So it actually has air infiltration that goes to the tub and whatever's next to the tub, probably the toilet here. And once it's in the wall, it's moving throughout the structure in general. So all things must have an air barrier associated with the entire envelope. And the one that's always a challenge is the tub and the plumbers in general, because why we ever let them use a Sawzall, I don't know, because they can create some massive openings for some very small pieces of pipe. So for those of you that are doing air sealing and you're doing insulation, these are the things that are commonly associated with one of the challenges. Is the plumber's usually the first in, sometimes after the HVAC contractor, but this is one of the things that has to show up. So now I actually have an air barrier and some insulation. It's not good, as you know, to have a void on the back, but some people just would come in later and just shove insulation in here without actually having the air barrier in place. So most people leave a couple of either fiberglass bats and some rigid board early in the game, or make sure the contractor is aware of that. Most plumbers aren't really taking care of that. So again, these are some other illustrations now. The knee walls must be completely encapsulated, so they must have some type of fire protected or rated backing on the backside, so there's no longer a possibility of just shoving insulation in or letting it fall off the backside of the attic. So many of these things you're familiar with or your practices, but these are also challenges to get to, depends on how the phase of construction goes. And this is what actually a good practice would look like, is that somebody actually came in and put an acceptable backer, and then it could be actually insulated from the interior side when all the other work is completed. Someone asked to, which kind of made sense just where I was at that previous slide, so let me just go back. Someone asked factors to consider for conducting a pre-drywall blower door test. So what you're needing is almost the same things that are needed for the insulation contractor to show up. Is that usually you're looking for a ceiling in most cases, unless you're doing spray foam on the roof deck. But in general, you're looking for walls to be open, and you're looking for a ceiling in place. So at this point, there's a lot of things that are kind of sealed up in general. Hopefully the windows are installed, and a variety of other openings are in place, and doors and windows. But I now actually have the interior open, but if I have a ceiling, which I'm going to use to put the insulation on in the attic, you can kind of get an idea at this point as to what's going on. If there's even large openings, they can actually be covered with rigid foam board or drywall or something to just find out if there's some really serious issues or challenges with what's happening with the structure at this level. Someone asked why I cover software in a single point test. I'll try and cover that towards the end. I do have some slides that are similar, but not directly towards that. So, Mike, I'll try and see if I can cover that. I mentioned earlier Pascals and just how subtle they are. So, if you're doing 1 inch of water column is about 200 and call it 50 pascals. So that's, if you imagine next time you drink water or tea or something at a restaurant with a straw, if you make marks on it that are just 1 inch, that's 250 pascals. And remember, we're only testing to 50, so it's a tiny, tiny bit. So usually, what I do is I'll make marks in the upper section of the straw and see if so you can learn how little pressure it takes to actually move the actual fluid inside the straw, which is the same type of pressure for Pascal. So blower door depressurization, I have a little animation that kind of explains the same thing. So we're all on the same page. We're visualizing that I have my blower door on. I've set it up to be negative 50 pascals. And basically what it's doing is going to pull all the air pretty much out of the interior, and also pull air in from any place else that has some kind of leak or concern. So while the test is actually running, I can actually go around with a smoke puffer, the back of my hand, and actually find many of these types of leaks. Many of them are just pretty obvious and common. You can actually feel them as you walk around the structure. Many of them actually show up on interior framing that have openings from either plumbers or electricians that are now connected to the attic or the crawl space. And now they also show up as receptacles. They show up as openings underneath the sinks. And all those should have been sealed actually at the top or bottom plates. It doesn't help to actually seal the receptacle. You really want to go to where the leakage actually is. And sometimes it's difficult to get to after the fact. So if you're testing and there's drywall up completely and you're failing, you're going to have some challenges as to how to actually resolve this condition. Someone asked about those step-by-step instructions. They're available at Southface. I'm sure it's southface.org. And maybe Jay can stumble through the actual link and send that out to everybody. They also have the illustrations that show, and they're actually the numbers coincided to the actual code section of the book, 1 through 17. And they also made a book on how to fix these things, on how to actually seal them correctly, following the same number system. So this is the math that kind of goes along with it. That air changes per hour is basically your CFM, which comes from the gauge on channel B. Those are your results. You times that by 60, and you divide it by the volume. So it can be, I've done it for quite a while, and it's still kind of a challenge for me to do this in my head. But one of the great features about the Retrotec gauges is it does this automatically. It doesn't just tell you CFM on channel B. It'll also give you an option of results. So I can do CFM. I can do CFM and use it for a different square footage for duct tester, or I can actually do it for air changes per hour. I can enter the volume on the gauge, and it'll tell me exactly what my air changes per hour are at 50 pascals. Here's kind of what air changes per hour look. So this is 6 air changes per hour at 50 pascals. So the blower door is running, and it's actually pulling all the air out of the house 6 times in 1 hour, again, with the blower door running. This is actually considered an average standard. We're headed towards 5. Some structures are headed towards 3. And it's all based on volume. The more volume the house has, the easier it is to pass this type of test or to become compliant. If the house is really small and it's on a slab, then you're actually challenged to actually achieve the type of numbers that are required. So you need to make sure that your area is following the challenges that are going along with other people about 3 air changes per hour with homes that are built on slabs. I kind of bring this up to kind of show you where the air barrier is. That most people just think of it as just kind of where the drywall is, but the reality is wherever anything is cut, and I actually have something installed there, then that becomes the air barrier. So here, my air barrier is in blue, and here's my supply duct, and the supply duct actually becomes part of the air barrier. So most people don't think of their duct system is actually part of the air barrier that separates the inside of the house from the outside. But as soon as I have a penetration in the wall or the ceiling, that's the line that gets followed. So if I actually have a hole or an opening in the duct system, then I actually have air that could penetrate directly, go directly into the interior of the house, whether the duct system is really on or not. Um, so if the duct system is running, now it's actually going to be bringing additional air in from outside or losing air to the outside, depending on where the leak is. So there are some leaky homes. I guess should get rid of that slide. Somebody asked about some of the different software. Here's one that I tried to bring up, and even though it has Wi-Fi on the image, it also works with a USB, so you do not have to have um, an actual Wi-Fi gauge to do this. It'll connect to USB, and it also works with the older style DM2. So for many of you that are out there that still have the DM2, the data logger is a free application you can download directly from Retrotec site, probably under software, or you can go to the gauge itself, and actually it has a separate section for software. And what this does is it allows me to keep track of whatever runs through the gauge live. So if you're looking for a QA process, something that keeps track of what I did, and I actually have quality control to document how I achieve these results, and I've kept them for somebody else to see. I can send them to somebody or share them with a code official or the builder or anybody that needs this to be done. Then this actually is a great process and application to do that. I do know that there's more and more communities, builders, and areas that are ResNet is requiring. That's getting in. They're doing the evaluation for the HERS rating, and a lot of times they actually have somebody else, not actually the HERS rater, do some of the testing. So if you're looking to expand your business, another way is to actually find a HERS rater that may be working with your builder, who may not be able or have the time to come out and test many of the structures. Again, that allows you to actually provide that service for him. And here's one way to actually show him exactly what you achieved. So I got my gauge going. I start logging. I stop logging, and it actually will show me the results on a CSV file. So it looks like an Excel sheet. I can do multiple gauges. It actually gives me the serial number of the gauge. So here I actually had 4 gauges together at one time, and it gives me all of the results from pressure A to B, or the results in CFM, or if I had air changes per hour. So this is a great way, again, to document your work, and you can also save that file on Dropbox, Google Drive, SugarSync, and it will keep track if you made any changes. So it's a great system to make sure what you're documenting actually stayed secured. On that note, I want to go to let's go to a few more questions real quick on the poll. Jay's got one here about select one more of the following. So why do you blower door test, or why might you, is the question there. Some people actually have code around them. Some people really don't. So I was trying to see what are some feedback as to what is your process that you may be using for a blower door test. I got about 60 in. Few more votes. What I'm after, and it's not my goal to try to be blunt, push equipment on anybody or sell anybody, but we try and create marketing opportunities or strategies for partner groups. So it's our goal to also see what we can't do about helping you market your blower door or your opportunities. So, okay, 2, 3, 1. I'm going to close your poll. And here's a phenomenal result that, without question, that people are after to give your business a competitive edge. And that's a great result. And if you're looking for more suggestions or process on how to do that, send us an email, and we'll gladly see if there's some way we can help you evaluate that, or a way to do that. So I have a few slides coming up on kind of other tests you can do or other ways you can use your blower door. All right, so I'll launch this poll ahead of that. Is what are some ways that you actually use your blower door right now? Most people are depressurizing. If you're not sure which way you test, the 99% of most blower door tests are run at CFM with results at 50 pascals, depressurizing. The only time you would pressurize is for a variety of options. One of which would be if the home was older home and you didn't want to bring any contaminants in, or the occupants had potential issues with indoor air quality, or for some reason you really were trying to make sure you didn't actually cause issues in the house itself. All right, I got the majority of folks in. For those of you that did other, give us some feedback as to, pardon me, what are some other things you may be doing. So as we predicted, 91% is depressurizing their blower door tests. As you probably are aware, the blower door test mostly allows me to compare one to the other for a home, as I mentioned earlier. Here's one method that you can use to add to how you're testing right now, and this is actually you can use a pressure pan, which basically is a large Tupperware container with some weatherization or material on it, so that you can actually push it up to something and it feels like you actually have a good seal and some kind of ability to actually put a hose into it. Retrotec sells them. So does Minneapolis Energy Conservatory. I make some myself that are just kind of smaller that I can use over a receptacle or something smaller in general. But what we're doing is we're going to set up the blower door test. So we have the blower door test, and it's depressurizing the house right now at 50 pascals in the same way I normally do. So it's the same test, and while the test is running, what I can actually do is use the pressure pan, which is this little set of black boxes up here, right? And all of the ducts are still wide open. Everything is open. And as I put my connected to the blue tube, which is the input on channel A, which is on top, and any kind of pressure that comes through here I'm reading 0.9 pascals. Anything kind of below 1 is considered an acceptable or a good standard. So what I'm looking for is any kind of leakage, like these yellow arrows are showing what kind of problems I might be having in this duct system. This will not tell me a compliance for duct leakage, but it will tell me a quality of how much my ducts leaks and where. If you're looking for existing homes, a lot of programs out there that HVAC contractors actually use something very similar. They get the blower door going, and then they go around and determine which ducts are leakiest. And they feel as though many times you don't need to do an actual duct test when you know where your significant leakage is, and you now know where to focus because you're going to seal the ducts anyway. So now I actually know that I may have more potential issues in some spots. So I got my blower door running, and I test this first supply duct. I go to the next one. Again, all the ducts are open. This one reads 6.8, all right, which is a significant number. And I go to the last one, and it reads 1.1. So I know now that my issue is probably somewhere between this beginning of the trunk or the end of the trunk. So this is one solid method of, again, diagnosing issues that may be happening in the duct system. The other thing I can do is I can take the same pressure pan and I can put it over a receptacle. I could put it over a junction box. I could put it over any kind of opening that is on the interior or exterior of the house, and looking for the same type of readings as to what I'm having. So remember that if I have 50 pascals, moving out of the house, then in theory I have 50 pascals moving into the house. So I can also use my manometer to determine how connected the attic is, or the garage, or the crawl space, that anything that reads, and it depends on Jay and I do things differently, depends on what else I'm comparing it to. But if I compare it to the interior, then anything in here is 0, 0, it's in the house. If I compare it to from the inside to the attic, then it actually should be 50 because the attic should be outside. Or if I put it over a receptacle on the wall and it reads 47, then I know I have connections between the actual wall and the outside of the house. So it may seem a little complicated or overwhelming to go through that, but I want to make sure that you knew there's some other options. Next month, I have a webinar that we'll do on what else will your existing equipment do. So we want to make sure we're covering some of those. My goal was to make sure you had an idea of how this could benefit you. So many of you responded by you actually use this as a competitive edge with your obviously with your competition. So I think it's a phenomenal resource. I highly encourage you to make sure that you're documenting all your equipment, making sure that it's up to date, that if anything needs to be calibrated, it is. All those are kind of the details that you want to make sure don't come back later to become a challenge for you. I personally think that if you're doing any kind of air sealing, the only way to confirm that it's done correctly is to test the structure. And I think if you're showing your contractors you're doing that or what kind of success you're having, that's a great way to either maintain the clients you have or get more clients in general. One of the things I do is sales, and it kind of would encourage you to ask contractors you're not working with as to who is testing your air sealing work that's done. And if it's not required for your code, you're going to find out that most of it is not. So there's no reason to do it, then it actually isn't done. So if you're going to be a competitive price and you include actually testing the envelope, that's a great feature for more business. The other place to actually take that same approach is with HVAC contractors. HVAC contractors are heavily dependent upon how well the envelope works in terms of being sealed. If the envelope is very leaky, it makes occupants very uncomfortable. So it's in the HVAC contractor's interest to make sure the envelope is well sealed and tested. So I highly encourage you to also think about working with HVAC contractors that may want to have the envelope tested so they can actually make sure that their sizing requirements are correct. And the one line that always gets HVAC contractors interested is when you explain that if there is a comfort issue with the occupants, there's really one person they're going to call, and that's the HVAC contractor, and ask them to figure out why they have comfort issues. And it doesn't work for the HVAC contractor to say, well, I have a manual J and a manual D, and I did all the specs. This system is installed correctly, because the homeowner's going to say, well, I don't care what manual you have. I really want to be comfortable. So I think there's a lot of great partnerships that are working well with contractors, HVAC contractors, and the air sealing contractor. And a lot of that comes right back to the installation installer. And when you're there to do put your insulation in, is the exact same time to be doing air sealing. Some people may be doing spray foam or a combination of spray and bat or whatever that is, but I think all those are a great opportunity for your industry. The one thing I did say at the ICAA at the committee is that energy auditors have had an identity challenge for several years as to how we fit in with the industry or regular contractors in general. And installation installers has a similar identity challenge because mostly people think of installation installers as just doing this one product. Maybe you have multiple solutions from either fiberglass, cellulose, or spray, but actually doing the air sealing is something that is going to be much more related to, I think, your part of the industry. Meanwhile, auditors are still trying to figure out what it is and sometimes how we fit in. So I think the more we bridge out and become auditors and partners with a variety of industries, and I think we all become successful in whatever part we do. So I threw some events up here. Colin is actually traveling. He is actually in Poland right now, and he'll be at the Tight Vent conference. He is there already. And next week we will have a QA QC with Retrotec software. It actually will cover more in depth about the software. So some of you had questions about that. Also in Belgium, Cullen Ginch will also be at the conference there. So if you're in Belgium or Poland, stop over and say hello. On October 7th, we have Wi-Fi gauges for weatherization professionals. And on October 7th and 8th, the ACA Building Performance Forum, I actually have a presentation that is the largest duct in the house, which is the envelope. And after I complete that presentation, I'll do that as a webinar. So we appreciate your time. It did go about an hour. I apologize if I messed up your lunch. I try to keep it under an hour, but there was a lot to cover today. Are there any other questions or anything I can answer before I end the session? Is there anything else you're looking to have as a webinar or a topic or subject or something that you want to see specifically more in depth? Then please don't hesitate to throw that in there. The PowerPoints will be online. It usually takes about a week to clean them up and do that. And but I do actually. There's very few things in here that I think are proprietary that it can't be done that way. I thought I'd show the